This is Forms of Linear Equations, Part 3. The final problem we looked at this week was called the cab ride. The given information was that you traveled 15 miles and had to pay $22.50. You also knew that the rate per mile in this cab was $1.50. This information allowed you to start a table. By first adding the point 15 miles and $22.50 onto the table, you could use the rate of $1.50 for every mile to add other points to the table. These other points are some examples. Once you had this table, it allowed you to write an equation. Many people wrote the equation y equals 1.5x. This equation is written in slope-intercept form, and it represents the situation perfectly. The only problem is that in order to write this equation, you couldn't go directly from the given information in the problem. You had to make a table first. So at the end of the exploration, they asked you to consider a second equation. It appears that this equation uses information from the problem, but are they equivalent? Let's start by proving this. After doing some algebra, we'll see that these two equations are equivalent. We'll start by doing the distributive property to get rid of parentheses. Next, we'll add $22.50 to both sides to isolate the variable y. By simplifying, you can see we are left with y equals 1.5x, which is equivalent to the original equation that many people wrote. So then how did we come about getting this equation in the first place? By taking the original information from the problem, we can write the point 15, 2250. We know this point is a solution to this equation because it falls on the line because we traveled 15 miles and had to pay $22.50. We can see the $22.50 show up in the equation because it's being subtracted from y, and the 15 is being subtracted from x. Finally, the rate of $1.50 per mile is showing up right outside the parentheses. The placement of these numbers is not a coincidence. This equation is written in point-slope form. The general form is written like this: y minus y1 equals m times x minus x1. It seems a little complicated at first, but it's actually really well named. The point is x1, y1, and the slope is m, just like we're familiar with. You can use the point-slope form when you're given the slope and one point on the line. It's especially helpful when you don't know the y-intercept. A graphing tip is to plot the point that you're given first. You can find that point by locating x1 and y1 and creating a coordinate point. Then you can use the slope to find additional points on the graph. When you think about point-slope form, think about the cab ride problem.